But 6.2b, properties of parallelograms. The first theorem says this: if a quadrilateral is a parallelogram, then the diagonals bisect each other. What does it mean to bisect? Cut in half, cut into equal parts, right? So if I have a parallelogram that looks like this, and I were to draw my diagonals in, okay, diagonal here, diagonal there, what they're saying is where they meet is a midpoint on both diagonals, okay? They bisect each other. They cut them into equal parts. So that means that this segment is congruent to that one, and this segment congruent to that one. Yeah, so diagonals bisect. Questions on that? Okay, so here's what you're gonna have to do with that. Let's say we have a parallelogram that is HIJK, and then we're given this is a length of A. It doesn't really look like an A. This length here is 2b minus 8. This one has a length of b, and then this has a length of a plus 2. Give you a second to draw that. Okay, so what did the theorem say? Diagonals what? Bisect, okay? So you have equal parts on the same diagonal. So what are we setting equal right now? What is A equal? 2b minus 8, okay? So A equals 2b minus 8, and B equals A plus 2, okay? What's the issue? Right, you're gonna have to substitute. We have two variables in both of our equations, so you're gonna have to substitute somewhere. It doesn't matter which way you substitute, you just need to substitute. So I would probably, just to avoid distributing, I would probably take this, what A equals, and put it in place of the A, right? So it would be B equals 2b minus 8 plus, plus 2. So if we simplify that, you have B equals 2b minus 6. If we take away that 2b, you get a negative b equals a negative 6. Sorry, my b's and 6's look a little too much alike. And then multiply by negative 1, b is going to be a positive 6. Okay. Once you know what b is, then you can solve for a by plugging it in up here. So a is going to equal 2 times 6 minus 8. So 12 minus 8, which means a would be 4. So a is 4, b is 6. How long is HJ then? How long is HJ?
8.
That would be 8, right? If we know A is 4, okay, that piece is 4. We know that it's bisected, so this would have to be 4 also, or you could plug in the value of B and you would get 4. So HJ would be 4 plus 4, or 8. Okay, what is IK? IK would be 6 plus 6, or 12. Okay, questions on that? God bless you. All right, the second theorem and the last main concept says this, and it's a little wordy, but you'll get it. It says if 3 or more, oh, what happened? That's not a word. There we go. If 3 or more parallel lines cut off congruent segments on one transversal, okay, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, here's what that means. If I have a bunch of parallel lines, so say these are parallel. I'm going to try and make that look a little more to scale. Sorry. Okay, so these are all parallel lines. What they're saying is if I were to draw a transversal in, so let's say I put a transversal here. Okay, as long as these are the same, then no matter where I put a transversal, it's going to cut equal parts out. So say I draw a transversal here. It's not saying that this segment is the same as this one. Okay, that's not what it's saying. What it's saying is that the segments it created with the transversal itself are congruent. So those two would be the same. Okay, or maybe I put a transversal here. Those two parts are going to be the same. As long as the first one is congruent parts, then every transversal is going to have congruent parts. Okay? Questions on that?
Yeah, I don't really get it.
Okay, let's add some letters in. A, B, C.
I get how it works in that diagram, but wouldn't the middle transversal have to be exactly in between, not the middle line, middle parallel line have to be exactly in between the other two parallel lines for that to work?
That's what they're saying is happening. They're saying this is congruent to that, right? So because those are congruent, then all the other ones have to be congruent as well. So yes, they're equidistant. Yes. Are you all good on that? Okay. Let me just write it out in symbol word form real quick, just in case. So it would be this. If AB is congruent to BC with these parallel lines, then DE is congruent to EF, and GH is congruent to HI. Okay? And we're just going to do a couple of those and call it good. All right, so second example here. Let's say we have 4 parallel lines. If I tell you with a transversal here and a transversal here, let's just name these. So A, B, C, D, and E, F, G, H. Okay. If I tell you that AB equals BC equals CD, which are all a length of 3. And then I tell you that EF has a length of 2.5. And I say find EH. That's hideous. I'm sorry. Find. What? No.
Oh wait, EH.
Okay, so take a look at it. It's saying this is 3, this is 3, that is 3. Okay? So you have congruent parts on the one transversal, and you have parallel lines, which means what about the other transversal? Congruent parts again, right? So if EF is 2.5, okay, so we know that piece is 2.5. What is FG? 2.5. Okay, then GH would also be 2.5. So we're looking for what is the length of EH, and that would be 7.5. So you're just adding those together so that EH is 7.5. Questions on that? Okay, one more quick one of that, and then we're done with the first one. That is really ugly. Sorry. We are. All right, so if I tell you AB is 5, BC is 5, you have parallel lines, and I tell you FE is 4, what is ED? 4, right? Same idea, it just got turned 90 degrees. So these are cut into equal parts because these were cut into equal parts. So then FD would be 8 units long. Okay, so don't let it throw you off because they turn it into a trapezoid instead of lines that keep going. It's the same idea. You still have the parallel lines, you still have equal parts. Yeah, questions on that?